Hello, welcome back to Math 8. This is a video over Section 5, and what we're going to be doing is using equations to represent trend lines, okay? So our objectives today, we want to find and interpret the slope of a trend line. We want to create the linear equation of that trend line, okay? So what we had done in the last unit was we had used Desmos to do that, okay? So we're going to do this, we're going to start doing this a little bit more. And doing it a little bit more by hand, okay? And when we calculate the slope of a trend line, we're going to interpret what that slope means, okay? So let's do this with this problem, slope of a trend line using data points. So Bella started running, and she kept the scatter plot of how many sunny days there were each month and how many miles she ran each month, okay? The trend line Bella drew goes through the points 1553 and 2266. So the question says, or the prompt says, use these points to determine how many extra miles Bella ran for every extra sunny day. Okay, so let's just calculate the slope. Okay, and let me zoom in here. And I'm going to call this x sub 1, y sub 1, x sub 2, y sub 2. All right, so if I calculate my slope, all right, we're going to get m is equal to 66 minus 53 over 22 minus 15, okay? Now, when I do this, I'm going to get 66 minus 53 is 13. 22 minus 15 is going to be 7, okay? So if we take 13 and divide it by 7, that's going to give me a slope of 1.857, okay? Let's go ahead and let's round this to the nearest tenth. So let's call this m is equal to 1.9. Okay, so now what does the slope mean? Okay, now remember, when we're talking about, slope, we want to use our labels to help us identify what this is going to mean. So we've got miles run and we've got number of sunny days, okay? So when I write this out, this is m equals 1.9 miles, okay, per sunny day, okay? And that's how I have to look at this. And so what we do is now that this allows us to answer the question, use these points to determine how many extra miles Bella ran for every extra sunny day. So as you're running, as the days go on and as you have more sunny days, Bella is running an extra 1.9 miles per sunny day. So let's write that down. So Bella is running an extra 1.9 miles on a sunny day, per sunny day. Okay, and that's it. All right, let's take a look at the next one. All right, so on this problem, on this one we were given data points. We're given 2 points that are actually on this graph, but on this one, we're going to be finding the slope of a trend line without having any points. Now we do have a graph that we can use, but we don't have any points that are going to be exact. Okay, so on this, let's just read through this problem real quick. Bella's sister Betty also keeps notes on her running. She records how many miles she runs and how many ounces of water she drinks during the run. Okay, so how does the length of the run affect how much water she drinks? So, one thing that you have to realize is that the longer the run, the more water she drinks. And we can see that based on this trend line because it's going up. As the miles increase, so does the water intake increase. So let's just write that down real quick. So the amount, let's write this. As miles increases, so does the water intake. Okay, that also increases. All right, and that's what we've got. All right, so now what I want to do is we want to figure out by how much. Okay, And so let's actually calculate some of these points. And let's just identify a couple of these points. Now, what we're looking for are actual points on the graph that we know for sure, okay? A lot of these points, like, the graph does go through this point, but I don't know exactly where that is, so we could kind of estimate it. However, one that we do know is right here on that graph, okay? And this is the point 6 at least, comma, and we're just going to estimate this to be 13 as a y value, okay? And then we also have this other point up here, okay, on that graph, and that's going to be the point 10, comma, 22, okay? Now, when I do that, all right, let's go ahead and use those points for our slope, all right? So I'm going to write those down. I've got 10, comma, 22, and then I've got, what is that, 6, comma, 13? 6, 13, 10, 22. Okay, so those are my points. All right, now what I want to do is calculate my slope, m. Okay, here's my x sub 1, y sub 1, x sub 2, y sub 2. All right, so my slope m is going to be 13 minus 22 over 6 minus 10. Okay, we're going to get negative numbers, but they'll cancel out and become positive. So 13 minus 22 is going to give me negative 9. And then 6 minus 10 is going to give me negative 4. So really we have a slope of 9/4. Okay, so my slope is equal to 9/4, which is going to be about 2.25, okay, if you divide those numbers out. Okay, and what I want to do now is identify what the slope means. So this means we're going to do 2.25 ounces per mile ran, okay? And so that's what Betty is drinking. So how does the length of a run affect how much water she drinks? So for every mile, she's going to drink 2.25 ounces of water, okay? And that's how we look at that, okay? All right, now on this one, we're going to be writing equations of trend lines. And so what we've already done is this is the same problem that we had in the very first top, in the top part of the page, and we have a slope of 1.9. Now what we want to do is use the point 1553 of the data to write the equation of a line. So we're actually going to write this line given this extra point on the trend line. Okay, so let's go ahead and do that. Nothing new. All right, so we have our slope m is equal to 1.9. My x value is equal to 15, and my y value is equal to 53. Now we're going to use the equation y equals mx plus b. All right, so I'm going to plug in 53 for y. I'm going to plug in 1.9 for m, and then I'm going to plug in 15 for x, and then plus b. So now what I'm going to do is I'm going to take 15 times 1.9, okay, and that's going to give me 28.5. So I got 53 is equal to 28.5 plus b. Now I want to subtract 28.5 from both sides. All right, so let me do that. Make sure you guys are writing small. There's not a ton of room in here. So minus 28.5. So 53 minus 28.5 is going to give us 24.5. So b is equal to 24.5. All right, so our equation for our trend line is going to be y equals, okay, 1.9x plus 24.5. And that's that, okay? And that's what we want to, have that in there, so we've got that. All right, so that is the equation of our trend line. Okay, now that's when we're given these points, okay, that are on the trend line. Okay, so just so we kind of see the steps here. Okay, so data given as a set of points. Okay, we want to make a scatter plot. Okay. We want to draw the trend line, find two coordinate points that are on the trend line, and then write the equation of the line in slope-intercept form. Okay, so we can do this by hand if we have the points. Okay, sometimes it's a little bit harder, but that's what we've got. So let's go ahead and do that on here. All right, so on this one, we have data for 7 years of a quarterback's passing statistics are shown by ordered pairs, where X is the number of passing attempts and Y is the number of interceptions, okay? So what we're going to do is we're going to go through, we're going to plot the points, okay, and then we're going to write the equation of this scatter plot, or of this trend line, okay? So let's go ahead and plot these, and this isn't going to be exact, but we're going to try and be as close as we can. So I've got 150, comma 4. Well, that one's pretty exact. That one's going to be right here. Okay, and then we got 252, comma 5. All right, so that's going to be right about here. 254, 8. Oops, 8. Okay. 296, 9. Okay, so we're right about here. Okay. And then the other one was 312, 6. Okay. 440, 10. And then 446, 12. Okay, so now I want to draw a trend line. Now I want to draw something that fits the data, okay? And so, you know, as I'm drawing this trend line, it's going to do something like that, where it needs to cut the data in half, okay? You know, and one of the other ways I think about drawing a trend line is that, you know, all my points are pretty equidistant to my trend line, okay? And sometimes they do go through. So now let's identify a couple of points that are actually on this graph, okay? The one that I'm going to identify is this one here and this one here, okay? And I'm just estimating these, okay? However, these are now my points that I'm going to use to write my equation. So I've got the point 150, comma 4. Okay, and then I've got the point 410. Okay, so now I'm going to use these 2 points to write the equation of my trend line. So I've got 150, comma 4, and I've got 400, comma 10. All right, so now I'm going to use these points. Okay, I'm going to call this x1, y1, x2, y2, and plug this into my slope formula. So here's what I got. I've got 10 minus 4 over 400 minus 150. So 10 minus 4 is going to give me 6. 400 divided by 150, or 400 minus 150, sorry, is going to give me 250, okay? And so if I take 6 divided by 250, okay, that's going to give me a slope of m equals 0.024, okay, and that's my slope. Now, the other thing that I want to do is write the equation of my line using slope-intercept form. So there's my slope. I'm going to use my smaller point, x equals 150, and a y value of 4. Okay, so if we use y equals mx plus b, okay, y is equal to 4, m is 0.024, x is 150, and then plus b. So 0.024 times 150 is 3.6. So I've got 4 is equal to 3.6 plus b. So I'm going to subtract 3.6 from both sides. Okay, and so I get that b is equal to 4 minus 3.6 is going to be 0.4. All right, and so I have my slope, I have my y-intercept, and here's my equation, y equals 0.024x plus 0.4. All right, so again, guys, you know, all we're doing here is we're using these points to draw you know, to write the equations of trend lines, okay? And that's what we've got. So sometimes you're given those points, sometimes you have to estimate those points, but you know, that's how we do that, all right? So That's all I got. We'll talk soon. See you in a bit. Thanks a lot. Bye.